All right, so first things first, let's talk about what rational functions are. So we're going to define that right here. It is a quotient of two polynomial functions. I'm abbreviating. Quotient of two polynomial functions. So f of x is equal to g of x over h of x. If you forget what that means, you need to know this word rational. Rational stems from the word ratio. Ratio means fraction. So we are talking today about fractional functions, functions that look like fractions, okay? Your parent function is f of x equals 1 over x. And if you remember what that looks like, that has these hooks in the corners. And so we're going to find out what happens with all of those kind of graphs. There are asymptotes in these pictures. And again, remember, an asymptote by definition is what the graph approaches. The graph approaches the line, but does not touch. Even though your calculator will say 0, and it looks like the blue line is laying on top of the asymptote, it's never touching it, okay? Your parent function looks like this. Again, I just want to kind of give you a visual. You have an asymptote right here at this line. All vertical lines, remember, are written as x equals, this is x equals 0, hoi vernox, remember that, vertical x. All horizontals go this way, and they're all written as y equals. And then there is a hook in that quadrant 1 and another hook in that quadrant 3. And that's just what the basic 1 over x looks like. But we're obviously going to be dealing with a lot of different ones today. So I'm more interested right now in you not being as accurate on the hooks as I want you to be more precise on knowing how to find a vertical and horizontal asymptote. You'll do that a lot next year in calculus as well. So now you're going to flip up your Foldable. What? Look at this. And we're going to talk about vertical asymptotes. Bless you. Okay? Now, vertical asymptotes, write this down, occur when the denominator equals 0. You have a vertical asymptote when the denominator equals 0. So this is going to be your first job on every one of these problems for homework tonight. You find out, when does that denominator equal 0? So let me give you an example right here. F of x equals 2 over x squared minus 9. So here's our example, 2 over x squared minus 9. You're going to go on the side of your paper, you're going to take your denominator. I like to write VA for vertical asymptote. And you're just going to set your denominator equal to 0. Can that factor?
Yes.
Into what?
3.
And?
Negative 3.
So where are my two asymptotes then?
3 and negative 3.
3 and negative 3. The way you write it, though, you have to write them as equations for these lines. So you'd say vertical asymptote at x equals 3 and x equals negative 3. And then what you do on this graph right here, you would go to 3 on the x, and you'd make a vertical dashed line. And then you'd make another one at negative 3. 1, 2, negative 3. Whoops. Make a vertical dashed line. The hooks, you're going to find them out from your calculator. Again, what my teacher used to make us do, there are 1, 2, 3, 4, 5, 6 sections, and we would have to plot a point. So we'd pick a point on the x-axis. I'd pick like 5, and I'd find out where 5 is, whatever quadrant it happens to be in, and I'd draw my hook. It's going to be like an upside down parabola and another hook. So it's just Right now, though, I'm more concerned about you knowing asymptotes. So vertical asymptotes when the denominator equals 0. That's easy, right? You can remember that. Horizontal asymptotes, on the other hand, there's 3 things that could happen. So flip this up. Foldable, foldable. Okay. So horizontal asymptotes are based off of the degree of the polynomial that is on top and the degree of the polynomial on the bottom. So there are 3 things that could happen. Those 2 degrees could be equal. The top degree, the numerator, could be smaller than the denominator. Or the only other choice it could be would be greater than. What that means is I have a possibility of 3 different types of horizontal asymptotes. So let me start with what if they're equal. So just to give you an example, zoom in here a little bit for y'all. Let's say I have 2x minus 5 over 3x plus 7, okay? So here's my polynomial. The degree on top is 1, the degree on bottom is 1. Do you all agree? Okay? If that happens, then your horizontal asymptote is what we call the numerical coefficient of that degree. The horizontal asymptote is the numerical coefficient. So what would be this numerical coefficient right here? 2 over 3. And so you would write y equals 2 over 3. That is your horizontal asymptote. When the degrees are the same, if this was degree 2 and this was degree 2, it still would be 2/3. If the degree on top is equal to the degree on bottom. Now, please just be careful. They move the degree around, obviously. They'll put it at the back or they'll put it in the front sometimes. Just look for it. Make sure it's the highest degree. So there's that one. Well, what happens if the top is smaller than the bottom? Okay. So if I had something like x plus 7 over x cubed plus 9. Now the top is 1. The bottom is 3. When the top is smaller than the bottom. Well, this one's actually even easier. Your horizontal asymptote is always y equals 0 when the top is smaller than the bottom. Always, always, always. Top smaller than bottom, y equals 0. Easy. Okay, so what happens if it's bigger then? So bigger, there is, well, there's a little option that's going to occur. So let me give you an example. 2x cubed plus 5x squared over 5x plus 10. Okay, obviously the degree on top is 3. The degree on the bottom is a 1. Top is bigger than bottom. Then this is what you're going to write. Your horizontal asymptote is none. There is no horizontal asymptote. However, write this on the side. You could have a slant asymptote. I'm going to put SA for now, and I'll talk about slant asymptote in the next one. But you could have a slant asymptote. This one actually doesn't have a slant asymptote. I'll show you how you'll know it with the next one we do. But your HA on this one would be none. You would write none. Don't write 0. 0 implies y equals 0. Okay? So really easy. These are the 3 possibilities for horizontal asymptotes. It could be the numerical coefficient if they're equal, y equals 0 if the top is smaller, or none if the top is bigger. Those are your only choices on tonight's homework. 0, none, numerical coefficient. Okay? All right, so cool. Our last one, this idea of a slant asymptote. What does that happen? What does it mean? And then I'm going to do 3 examples, and then we're going to be done. Okay, so first of all, slant asymptotes, they only happen when there is no horizontal. If you have a horizontal asymptote, you are not going to have a slant, okay? Just FYI. You can't have a horizontal asymptote and slant asymptote happening at the same time. Okay, but here's how you know you have a slant asymptote. If the degree of the numerator, oops, NUM, if the degree of the numerator is bigger than the degree of the denominator by 1 degree. Not by 2, not by 3. If the top is bigger by 2, then you just have no horizontal asymptote. But if it's bigger by 1 degree, then you have a slant. So to give you an example, x squared plus 9x plus 3 divided by x. Okay? So let's go through this one, VAHASA. Let's see if we can figure this out. Let's start with VA. How do I know what a vertical asymptote would be in this one? Set the denominator equal to, so when would that be 0? X equals 0. Horizontal asymptote, you look at the degrees. The degree on top is 2, degree on bottom is 1. If the top is bigger, then you automatically write none. If the top is bigger, none. Is it bigger by 1?
Yes.
Then you have a slant. So how do you find that slant asymptote? It's pretty cool, actually. You find it by doing long division and write as y equals mx plus b. And I'll explain what that means in a minute when we do this problem here. Find it by doing long division and write it as y equals mx plus b. So I know you don't like long division, but you have to do it for this one because under here won't always be x or x minus 3, and you're like, oh, we can just do synthetic division. You could, but if it's x squared plus 5x plus 7, you have to do long division. So just to refresh on how to do long division, it's really quite simple. You look at your first term x, and how does it become the first term x squared? X, multiply, subtract, bring down. How does this x become 9x now? Plus 9. You can stop right after 2 times of doing this. Here's why. Isn't this in the y equals mx plus b form? Mx plus b? You only have to do long division those 2 times. That's all your long division, if you're doing it correctly, should only be done twice. So what does that mean? Well, let me just kind of give you a little visual on what this looks like. So you have x equals 0, which is this vertical line right here. And then you have this slant right here, this slant asymptote, y equals x plus 9. So that means you would actually go to 9, make a dot, and then rise 1, run 1, or go down, go down. So you have this slant asymptote this way. And then your hooks, I believe they're actually going to go in here and then up in here. I'll let you use your calculator for that. The hooks could go here and here. They're always opposite each other, those hooks, but you can actually, again, find them out. You can plot a point right now and then find out where it would be. But it's pretty cool to me. Like they actually make it, they slant, they come along that slant right there, that y equals mx plus b line. All right. So that's how you do all of them, but we're going to do just 3 examples together right now, and then we're done. I want to make sure that you've got how to do this tonight. Aren't you loving this foldable? That's what I want to hear. I want the love. I want the love for the foldable. All right, so flip it over on the back. Let's do 3 quick examples of what, and this is how I want you to do all of your homework tonight. Okay? I want it, do it my way. Don't necessarily do the directions. I think the directions say find the domain tonight. I don't need you to do that. I mean, we've tested you on domain. You should know how to do domain. All right, but here's what I want. I want VA and HA written over here on the side. Okay? So you're going to start with your VA. Vertical asymptotes, you do what? Set the denominator to 0. When is that denominator going to be 0?
2.
2. So x equals 2. Horizontal asymptote is based off of the degree. The degree on top is 1. The degree on bottom is 1. If they're equal, then it's your what? Coefficient. What's the coefficient in front right here? You would write y equals 3. So then on your homework tonight, and I just want a quick sketch, you're going to go to x equals 2, make a dashed line. You're going to go to y equals 3, 1, 2, 3, make a dashed line. Then to determine where the hooks, you can plot a point if you want to, but you can just plug it in your calculator. I'll let you plug it in your calculator. The hook would be actually up here, and then the other one would be right here. Easy. Not hard. That's what I want tonight. All right, let's do another one. Y equals x squared plus 3x minus 15 over x plus 4. This one? I don't know, maybe. Is it? I didn't think it was. I'm sure. All right, again, VA, Vertical asymptote, set the denominator equal to 0, and what do you get for x? Negative 4. Horizontal asymptote is based off of the degree. The degree on top is 2. The degree on bottom is 1. If the top is bigger than the bottom, no matter what, you're going to write none. If the top is bigger than the bottom by 1, then what do you have? I have a slant. Okay? So I'm going to do long division. X plus 4 into x squared plus 3x minus 15. Again, if I do it correctly, I should only have to do long division twice. So how does an x become an x squared? X. Multiply by both. X squared 4x. And by the way, if you forget this changing of the sign, you will mess up this slant asymptote. God bless you. Negative x, bring down minus 15. How does an x become a negative x? Minus 1. That is done. You don't have to find a remainder. You don't have to do anything more. You just stop right there when it looks like mx plus b. You just stop. And then you graph it on your grid. You just make a little grid here. Let's see. X equals negative 4. 1, 2, 3, 4. Make a dashed line. There's no horizontal asymptote. And then y equals mx plus b. So I'm going to start at negative 1. And I'm going to go up, over, or down, left. So I'm going to go this way. So make a dashed line there. And then let your calculator find the hooks for you. I'm okay with that. The hooks on this one are actually this way and this way. So pretty opposite from what we did before. Okay. And then there's one different one I want to show you, and then we're done. That's all about rational functions. I got to put it over here. Y equals x squared plus 4x plus 3. Okay. On this one, you are going to have to start differently than the rest of them. Like, you're like, oh, Mrs. Seta, you always did vertical, but I hope by the time you're at this level that when you see a trinomial, what do you intrinsically want to do? Okay, and that's what you should be doing first on these. So you actually want to factor this top first. You might want to write that down. Factor first. Okay. And what two numbers multiply 3 but add to 4? 3, 1. Huh. Well, what you've just now noticed is you have a factor on top and a factor on the bottom that would actually cross off. Agreed? When a factor crosses off in mathematics, when you're graphing it, that is actually called a hole in the graph. There is a hole at x equals negative 3. Where am I getting negative 3 from? You're setting it 0. Yeah. Okay. There is a hole. Listen to me. That is not an asymptote. Holes are holes in the graph. You actually have this hole sticking there that you didn't know existed. It's not an asymptote. So you don't want to do the VA first. You want to see if something crosses off. If it crosses off, it's a hole. Next year in calculus, we actually changed that name. It's no longer called a hole. It's called a removable discontinuity. It's fun. I know. Why did they change it? Don't ask me. I didn't do it. So your vertical asymptotes are now where? At 0 and then at 2. You do not have a vertical asymptote at -3. Your horizontal asymptote, again, that's based off of the degree. The degree on top is squared. What's the degree on bottom if you have 3 x's? What's the degree?
3.
Degree 3. So the top is smaller than the bottom. What's our horizontal asymptote then? 0. So then this picture would look like this. And I'm going to change to green so you can see the asymptotes a little bit better. You have a vertical asymptote at x equals 0, which is right here along the y-axis. You have another one at 2. And then you have another one at y equals 0. Okay? When you put this in your calculator, it's going to look really weird, especially if you have the black and white calculators. They'll draw this hook, but it'll look like it'll stop right there. And it doesn't, okay? The hook keeps going. It's just getting very, 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 very tight to that asymptote. The other thing it'll look like is, it'll look like this hook is like that. And that's not true either. I don't know why the calculator can't do this. I think it's just because it can't graph such minute, small numbers, but it actually is an upside down parabola looking like that, surprisingly enough. The other hook is up in here. So this one actually has 3 different ones. But the cool thing is right here at -3, 1, 2, 3, there is an actual hole in the graph. You won't see it on your calculator, but if you go to the table, it'll say error at -3. So what I want you to do is I actually want you to draw in that hole. All right, but this is it. This is your foldable. Use this tonight for homework. Wasn't that fun? It's really a good, I'm really proud of my foldable. Can you not tell how proud of my foldable I am?
No.
It's really, really good.